Okay, so now we're going to do question 1. In 1.1, we are asked to solve for x. We're going to start with 1.1.1. So we're having x squared minus 4x plus 3 is equals to 0. So the first step we're going to do, we're going to factorize. We equate to 0. So the factors of x squared is x and x. Factors of 3 such that they give us the middle term is 3 and 1. So we're just going to make them negative, both of them. And then we're going to say x minus 1 is equals to 0, or x minus 3 is equals to 0. So x is equals to 1, or x is equals to 3. So these are our x values. 1.1.2, where we're going to write our solutions to 2 decimal places. So we have 5. So we have 5x squared minus 5x plus 1 equals to 0, and our quadratic formula is equals to minus b plus or minus the root of b squared minus 4ac divided by 2a, and our value of a is equals to 5, our value of b is equals to minus 5, our value of c is equals to 1. So we're going to say x is equals to minus, substitute our value of b, which is minus 5, plus or minus the root of minus 5 squared minus 4, our value of a being 5 and our value of c being 1, divided by 2 and our value of a being 5. So your solutions of x are supposed to be x being equals to 0.72 or x being equals to 0.28. So these are your solutions of x for this problem here. We're going to do 1.1.3, where we're going to solve this inequality problem here. So we're having x squared minus 3x minus 10 is greater than 0. So we're going to first factorize this problem here, right, and find the factors of x squared being x and x. Factors of 10 such that they give us the middle term is 5 and 3. So the larger number takes the sign of the middle term, so it's going to be negative, and this 3 is going to be. So we're having x squared minus 3x minus 10 is greater than 0. Then we're going to write the factors of this problem here. So the factors of x squared is x and x. The factors of 10 such that they give us the middle term is going to be 5 and 2. 5 is going to be negative because it's going to take the sign of the middle term, and 2 is going to be positive. Then because this is an inequality and we are trying to solve for x, we're going to write our critical values. So our critical values are x plus 2 equals to 0, or x minus 5 equals to 0. So x is equals to minus 2, or x is equals to 5. So these are our critical values, right? So remember that we want solutions of x such that they give us y values that are greater than 0. So anything that is greater than 0 is positive. So that is the aim for this problem here. So the first thing we're going to do now, we're just going to write our number line and present our critical values. So we have a critical value of minus 2 and a critical value of 5. So then what you can do is, okay, let me write critical value, critical value. So we're going to test values before our critical values and after our critical value. So the first value that we're going to write here is -3, which is before our critical value of -2, and a critical value that is between our critical value of -2 and 5. We can say 2, right? And a critical value of 5. So we're going to test a value that is greater than this critical value of 5. Let's say 6, right? So you're going to test these values and identify the values of y, right? So you're going to substitute these values in your equation of 5x squared minus 5x. So you're going to substitute these values in your equation of x squared minus 3x minus 10, right? So you will start with your x value being equals to -3. So you're going to substitute it here and find your value of y. You'll find that your value of y is going to be positive in this case. So whatever value it is, it's just going to be positive, right? So this means now that any value that is less than -2 is going to give you a positive value of y, right? And then you're going to try out x being equals to 2, right? And then you'll find that your value of y is going to be negative. So this means now that any value that lies between -2 and 5 will give you a negative y value, right? So you're also going to try x being equals to 6, this one here, and you'll find that your solution of y is going to be positive, right? So this means now that any value that is greater than your critical value of 5 is going to give you a positive solution of y. So remember that we are interested in positive solutions of y because our inequality is greater than 0. So we can conclude by that, right, using our critical value of -2 and 5, and say our solution of x must be less than -2, right, for us to get a positive solution of y, or x must be greater than 5 for us to get a positive solution of y. So these are our solutions for this problem here. Do 1.1.4. You're going to solve for x for this third equation. So we're having 3 root of x being equals to x minus 4. So the first thing we're going to do is we're going to square both sides, right? Then we will have, so this squared will square this 3 and this root of x, right? So you're going to have 9x being equals to, so let's expand this. We will have x minus 4 and x minus 4, right? So let's find the product of this problem here using our FOIL method. So we're going to say 9x being equals to x squared minus 4x minus 4x plus 16. So you have 9x being equals to x squared minus 8x plus 16. Then we're just going to transpose this 9x to the other side. So you're going to have x squared minus 8x plus 16 minus 9x equals to 0. And then we collect the like terms and write in standard form. So you're going to have x squared minus 8x minus 9x plus 16 being equals to 0. And then we're just going to write our x squared minus 17x plus 16 being equals to 0. Then we factorize from this point here. So we're going to have x and x, factors of x squared, and factors of 16 such that they give us the middle term is going to be 16 and 1. So we're going to have negative both factors. Then x minus 1 equals to 0, or x minus 16 equals to 0. So x is equals to 1, or x is equals to 16. Remember, this is a third form equation, so we need to test each value of x and define whether it is working, right? Whether the left hand side is equal to the right hand side, right? So I did my checks and concluded that x is not equals to 1. So there's only one solution of x here, which is x being equals to 16. Now we're going to do 1.3, right? And we are given if 3. Okay, so now we're going to do 1.3, right? And the statement reads as follows: if 3 to the power of 9x is equals to 64, and 5 to the power of root of p is equals to 64, calculate without the use of a calculator this expression here, right? So what we need to note is this: we're having 3 to the power of 9x being equals to 64, and we're having 5 to the power of root of p being equals to 64. So we need to note these expressions here before we solve. So we are given an expression of 3 to the power of x minus 1 all to the power of 3 divided by the root of 5 to the power of root of p, right? So the first thing we're going to do here, we're going to solve this root of 5 root of p, right? I'm gonna say but the root of 5 to the root of p, right, is equals to 64, right? Remember that 5 to the root of p is equals to 64, right? So what we're gonna do is we're gonna say, okay, fine, it's equals to 64, but it's not really equals to 64 because it's 5 root of p being equals to 64, right? So for us to remove this square root, we need to square so for us to we are given that 3 to the power of 9x is equals to 64, and we are also given that 5 to the power of root of p is equals to 64. Then our expression is given as 3 to the power of x minus 1 all to the power of 3 divided by root of 5 to the power of root of p, right? So what we can do is we can solve the bottom, right? If you take a look, let me do this. If you take a look, let's solve this. Yeah, we're having 5 to the power of root of p being equals to 64. So if we put a square root on 5, then it means we have to put a square root on 64, right? So once we put a square root on 5, it makes it similar to the bottom, right? So now we know that the root of 5 root of p is actually equals to 8, right? Because the root of 64 is 8. So let's take the positive 8 and not the negative 8. So now we know the substitute of root of 5 root of p. So instead of writing this root of 5 root of p, we're just going to write 8, right? And then looking at this 3 to the power of 9x equals to 64, we're going to write 3 to the power of 3x all to the power of 3, right? So just simplifying this 3 to the power of 9x, right? So we know that if you multiply this 3 inside, it's going to still give you 3 to the power of 9x, right? So it's equals to 4 all to the power of 3, right? So which we know 4 to the power of 3 is equals to 64. So then these 3 will cancel out, so you will have 3 to the power of 3x being equals to 4. So whenever we see 3 to the power of 3x, we're just going to substitute it with 4. Now let's simplify the top before we substitute what we just found. So we're going to have this 3 will multiply everything that it finds inside, so it's going to be 3 to the power of, so let me write it here aside. So it's going to be 3 to the power of 3 into x minus 1 divided by the root of 5 root of p, right? So the 3 will multiply everything inside here, so it's going to be 3 to the power of 3x multiplied by 3 to the power of minus 3 divided by the root of 5 root of p, right? Remember I said the 3 to the power of 3x is equals to 4. So instead of writing this 3 to the power of 3x, we're just going to write 4 equals to 4 multiplied by 3 to the power of minus 3 divided by, and also remember I said instead of writing root of 5 to the power of root of p, we just going to write 8, right? Because it's equals to that. So we're just going to write 8 at the bottom here, right? So and then we're having, so we know very well that 4 goes twice in 8, so we will have 3 to the power of minus 3 divided by 2, right? Because 4 goes twice in 8. Then we will have, let's just take this 3 to the power of minus 3 to the bottom, so we have 1 divided by 2 multiplied by 3 to the power of 3. So 3 to the power of 3 is 27, so multiplied by 2 will give you 54. So it's going to be 1 over 54. So this is the solution for your problem here. Right, so now we're going to do question 2. 2.1, we are given a quadratic sequence of 2, 3, 10, and 22. And 23, sorry. So 2.1.1, we are asked to write down the next term of the sequence. So so we have 2, 3, 10, 23. So we are asked to write down the next term of the sequence. The first thing we're going to do is find the first difference of this sequence here, which would be 1, 7, and 13, right? So the second difference is going to give you 6, right? So we know that the sequence is increasing by 6 points or 6 units, so meaning that the next term here would be 19 and the following term would be 25, right? So then for us to find the next term, we're going to say this 19 plus this 23, so it's 19 plus the 23 here. Add them together, they should give us the next term, which is 42, right? If maybe you want to find another term, you can simply say this 42 plus 25 should give you 67. So this is the answer for this question here. So 2.1.2 says that we must find the nth term of the sequence. So basically we must find the general term or the equation of this quadratic sequence. So what you want to do is, we know our sequence is 2, 3, 10, 23, and 42, which we found in the previous question. So we need to find the first difference of this sequence here, which would be 1, 7, 13, and 19, right? Because we say 3 minus 2, 10 minus 3, 23 minus 10, just like that. So this would be our first difference, right? And our second difference, we just subtract these. 7 minus 1 gives you 6, and 13 minus 7 is 6, 19 minus 13 is 6. So this is your second difference, right? So to find, because Tn is equals to an squared plus bn, plus c, we first need to find the value of a, right? So it's going to be 2a is equals to the second difference, which is 6, and then we divide by 2 both sides. So our a value is going to be 3, right? And then to find the value of b is going to be 3a plus b is equals to the first term of the first difference, which is 1, and 3 into our a value is 3 plus b is equals to 1. 3 times 3 is 9. And transpose it to the other side, we have b is equals to 1 minus 9, which b is equals to minus 8, right? So and then we want to find the value of c, so it's going to be a plus b plus c being equals to the first term of the sequence, which is this 2 here, so it's going to be 2. The a value is equals to 3, the b value is minus 8, plus c is equals to 2, right? So your c value is supposed to give you 7, right? So now you have your a value, your b value, and your c value. So your formula is going to be Tn being equals to an squared plus bn plus c, of which your a value is 3, so it's going to be 3n squared. Your b value is minus 8, it's going to be minus 8n, and your c value is equals to 7, so it's plus 7. So this is your Tn of the sequence here. 2.1.3 says that we must calculate the 20th term of the sequence. So we already found our Tn, right, being equals to 3n squared minus 8n plus 7, right? So T20 would be 3 into 20 to the power of 2 minus 8 into 20 plus 7. So you need to get an answer of 1041, right? So that is your T20. So now in 2.2, we are given this arithmetic sequence of 35, 28, and 21. We are asked to calculate which term of the sequence will give us a value of minus 140, right? So we are given a sequence of 35, 28, and 21, which we are told it's an arithmetic sequence, right? And we are asked which term of the sequence will give us minus 140, right? So we need to find the value of n, basically. So because the arithmetic sequence, you're going to use the general formula of an arithmetic sequence, which is Tn is equals to a plus into n minus 1 multiplied by d. So our Tn is minus 140 is equals to our a value, it's our first term of our arithmetic sequence, which is 35, plus into n minus 1. Our difference of these is going to be minus 7, right? So we're just going to write minus 7 here, right? So then we can transpose this 35 to the other side. We have minus 140 minus 35 is equals to n in, it's equals to n minus 1 multiplied by minus 7, right? So we can simply divide by minus 7, so we divide by minus 7 both sides. We have n minus 1 is equals to minus 140 minus 35 divided by minus 7, and transpose the minus 1 to the other side, and we will have n being equals to minus 140 minus 35 divided by minus 7 plus 1. So our n value, if you're going to punch this into your calculator, you should get an n value of 26. So that is what we are looking for in this question here. 2.3 says that for which value of n will the sum of the first n terms of the arithmetic sequence, so the sum of the arithmetic sequence in 2.2, which means in the previous question that we just did, be equal to the nth term of the quadratic sequence in 2.1. So this is the quadratic. So we want to find the number of terms such that the sum of the arithmetic sequence is equals to the nth term of the quadratic sequence. So our equation should look something like this. So We know very well that Sn is equals to n over 2 into 2a plus n minus 1 multiplied by d, just like that for an arithmetic sequence, right? And our Tn we found to be equals to 3 multiplied by n squared minus 8n plus 7, right? So the first thing here is to do is to equate these two equations and find your value of n, which is what's required. So Sn is equals to Tn, right? And our Sn is this equation here, so it's going to be n over 2 into 2a plus into n minus 1 and multiplied by d equals to 3n squared minus 8n plus 7, right? So we need to write down our values of the arithmetic sequence. If we take a look, this is our arithmetic sequence of 35, 28, and 21, right? So what this means is it will be easier for us to identify the a value and the d value of the arithmetic sequence here. So the a value and the d value, right? Because we're having our a value, so it's going to be n over 2 into 2. Our a value from that sequence is 35, right? Plus into n minus 1, and then our d value is minus 7. This is what we identified in the previous question. So it's equals to 3n squared minus 8n plus 7, right? So just going to simplify this further. So it's going to be n over 2 into 70, right? Because it's 2 times 35. And then this minus 7 will multiply everything that is inside here. So it's going to be minus 7n plus 7 is equals to 3n squared minus 8n plus 7, right? So it's going to be n over 2 into minus 7n plus 77 is equals to 3n squared minus 8n plus 7. So we're just going to multiply the n over 2 inside. So it's going to be minus 7n multiplied by n over 2 plus 77 multiplied by n over 2, right, equals to 3n squared minus 8n plus 7. So here we're going to get minus 7n squared over 2 plus 77n over 2 equals to 3n squared minus 8n plus 7, right? So we're going to collect the like terms, meaning that we're going to add this minus 7 over 2n squared with this one here, and we're going to add this 77n over 2 with this minus 8 here, right? So remember that this is actually 7, this one here. So once we add these like terms, we should have a standard formula of 13 over 2 n squared after adding this with this here, and then we will have minus 93 over 2n after adding this and this here. So you can decide whether you take this left hand side to the right hand side and then you do the addition and subtraction, or you take the right hand side to the left hand side and do the addition or subtraction, right? So what I did is I took this everything here to the right hand side and then I added and subtracted the terms. So you're gonna have plus 7 being equals to 0, and then from here you can use your quadratic equation, right? Quadratic formula rather, which is n being equals to minus b plus or minus the root of b squared minus 4ac divided by 2a, right? So you're going to substitute your value of b. In this case, it's minus 93 over 2. Your value of a is equals to 13 over 2, right? And your value of c is equals to 7. So you will substitute these values into your quadratic number pattern. So you're going to say n is equals to minus our bit minus 93 over 2 plus or minus the root of minus 93 over 2 squared minus 4. Our a value is equals to 13 over 2. Our c is 7, right? And then divide by 2. Our a value is 13 over 2. And then the final answer that you're supposed to get is n being equals to 7 or n being equals to 2 over 13, of which this is not applicable. We will take n being equals to 7. So this is question 3, right? We are given a geometric series has a constant ratio of 1 over 2 and a sum to infinity of 6. 3.1, we are asked to calculate the first term of the series. So we have a sum to infinity being equals to a over 1 minus r, and we're given the sum to infinity to be 6 being equals to, we want to find the value of a divided by 1 minus 1 over 2, right? And then it's going to be 6 multiplied by 1 minus 1 over 2, right? So I'm just cross multiplied here, equals to a. So your a value, therefore your a value is going to give you 3, right? So you're just going to put this inside your calculator and you'll find the value of 3. Okay, so now 3.2, we are asked to calculate the 8th term of the series, right? So now we know that a is equals to 3, we know that r is equals to 1 over 2, right? So now to calculate the 8th term, so we know that the general term of a geometric, because this is a geometric series, Tn is equals to a r to the power n minus 1. So T of 8 is equals to our a value, which is 3, our r, which is 1 over 2 to the power of 8 minus 1, right? So what you need to find is 3 over 1 to 8. So this is the final answer. Now 3.3, given this sum to 3.3, we are given this sum here and we are told that it's equals to this value here, and we're asked to find the value of n, right? So what you're going to do is this: you're going to identify first the first 3 terms and then identify whether it is a geometric or arithmetic, and then find what is required. So we're having the sum. At the top it's n, k is equals to 1, and we have 3 into 2 to the power of 1 minus k, and you're told, so this is k, and you're told that it's equals to 5.8125. So the first thing you're going to do is you're going to say, when k is equals to 1, 3 into 2 to the power of 1 minus 1, it's equals to 3. If you punch your calculator, when k is equals to 2, 3 into 2 to the power of 1 minus 2, it's equals to 3 over 2. When k is equals to 3, 3 into 2 to the power of 1 minus 3 is equals to 3 over 4, right? So the first 3 terms of this sequence here, or this series rather, is 3 plus 3 over 2 plus 3 over 4, right? So to find n, right, remember that this n here, number of terms is equal to top minus bottom plus 1. So the top is n minus the bottom is 1 plus 1, so n is equals to n, right? So we can consider it as the number of terms now. So to find n, we know that Sn is equals to 5.8125, right? And we just want to find n, right? Because a value is equals to 3, d value is equals to not d but r is equals to 1 over 2, right? So to find the sum is equals to a into 1 minus r to the power n divided by 1 minus r, right? So we are given sum to be 5.8125 equals to, and the value of a is 3, right? So it's going to be 3 into 1 minus value of r is 1/2 to the power of n divided by 1 over 1 minus 1 over 1 minus half, right? So we're just going to cross multiply here, cross multiply. So we're going to have 5.8125 times 1 minus 1/2 equals to 3 into 1 minus 1/2 n, right? So we're going to divide by 3, divide by 3. 5.8125 times 1 minus 1/2 divided by 3 minus 1 is equals to minus 1/2 to the power n, right? So in this expression here, this entire expression here, plug it in your calculator and you should get minus, so this is what I just wrote, and it's equals to minus 1/32, right? So this negative goes away. We have 1/2 to the power n is equals to 1/32, right? So 32 can be written as differently. Okay, before I even do that, we can simply say n is equals to log our base is 1/2 and multiplied by 1/32, right? So which is equals to 5. So therefore n value is equals to 5. Now we are going to do 3.4, right? And we are told that if this sum is equals to p, if this sum is equals to p, write down this in terms of p, right? So we are told that if the sum 20 terms, k is equals to 1, excuse me, 3 into 2 to the power of 1 minus k is equals to p, and then we must write this sum here of 20, k is equals to 1, 24 into 2 to the power of minus k in terms of p. So for us to do that, we have our sum of 20, which is this one here. K is equals to 1, 24 into 2 to the power of minus k. So you have to manipulate this problem here to make it similar to this one here, because almost everything is similar. It's just this 24 that is not similar to this 3 here. So we can just simplify and say we have the sum 20, k is equals to 1, and 4 times 3 is 12, times 2 is 24, and then 2 to the power minus 4, like that. And then we say the sum 20 times k is equals to 1, and then we are going to say this 2 here, it's to the power of 1, right? So we can simply say 4 multiplied by 3 multiplied by 2 to the power of 1 minus k, right? So this is k minus k, right? And it's almost similar to this one now. Just need to remove the 4, right? So this is how we can do it. Can simply say the 4 here, sum 20, k is equals to 1, and we have 3 multiplied by 2 to the power of 1 minus k, right? But remember that the sum when k is equals to 1 of 3 multiplied by 2 to the power of 1 minus k is actually equals to p, But since that is only this portion in this equation, this is the only portion, so you can equate it to p. So therefore x therefore 4 multiplied by, so the entire thing here is equals to p multiplied by p, therefore it's 4p, so that is your sum. So we are given this diagram below with a graph of f of x being equals to ax squared, drawn at an interval of x is less than or equals to 0, and the inverse is also drawn, right? So p, which is this one here, is a point on f, and r is a point on f inverse, right? So we are given this diagram. So now 4.1, we are asked to determine whether the inverse of f is a function. Yes, it is a function, reason being it is actually a 1 to 1 function, right? So this is the inverse. It is a function because the value of y is equals to the value of x, or vice versa. So yes, we have done this question here. And then 4.2, if r is the reflection of p in the line y is equals to x, write down the coordinates of r. So if r is the reflection, so here it's the equation of y is equals to x. This is the one, goes all the way like that, so y is equals to x, right? So if it's a reflection of p in this line of y is equals to x, therefore r is going to be the vice versa, this there and then that there, right? So it's going to be minus 12 and minus 16. So r is going to be minus 12 and minus 6. So that is the value of r. And then 4.3, calculate the value of a, right? So we have f of x being equals to ax squared, right? And we can use a point to find the value of a. The point of p, remember that p is passing through the graph of f, so p is actually minus 6 minus 12. So we substitute into the equation, so we have minus 12 is equals to a into minus 6 squared. Minus 12 is equals to 6 squared is 36a, divide by 36, divide by 36, so our a value is equals to minus 1 over 3, right? So let me write it properly. So it's minus 1 over 3, so this is our a value. And then 4.4, we are asked to write down the equation of the inverse. So we have f of x equals to ax squared, right? But a is equals to minus 1 over 3, so f of x equals to minus 1 over 3x squared, right? So we need to write down the inverse of this. To write down the inverse, this is y is equals to minus 1 over 3x squared, of which when you swap, this is x being equals to minus 1 over 3 y squared, and then we're going to cross multiply, so it's going to be 3x equals to minus y squared, divide by negative 1 both sides, so it's y squared is equals to minus 3x, right? So y squared is equals to minus 3x cool, but we're not done, because it's y to the power of 2. Y to the power of 2 is equal to minus 3x, so we have to put the square root, and therefore y is equal to the square root of minus 3x. So this is the final answer of this problem here. So this would be your inverse of f. Okay, so now we're going to do question 5, where we are given this function of f of x being equals to minus 1 over x minus 1, right? So 5.1 says that we must write down the domain of f, right? So when you talk of the domain, we're basically talking of the x values, right? So we are interpreting the movement of x values. So for a hyperbola, we simply write the domain as x is the element of real numbers, but x is not equals to 1. So we're going to use this vertical asymptote of x minus 1 here, right? So it's going to be x element of real numbers when x is not equals to 1. So this means now that the graph, the values of x move from negative infinity to positive infinity, but they do not touch x equals to 1. Fine. So now we're going to do 5.2. We're going to write down the asymptotes of f, right? So the vertical asymptotes that we have here is 1, right? We're using this one, x minus 1. And then the horizontal asymptote is 0 because there is no value of q here, right? So these are our equations of asymptotes. Now we're going to do 5.3, which says that we must sketch the graph of f, clearly showing all intercepts with axes and asymptotes. So I'm just going to draw the graph on this side here, but before we draw the graph, we need to identify our intercepts. So when x intercepts, y is equals to 0. Remember that we have our function f of x being equals to minus 1 over x minus 1, like that, right? Just to confirm, yes, that's how our function looks. So now we're just going to write our x-intercept when y is equals to 0, right? So it's going to be 0 is equals to minus 1 over x minus 1. So when you cross multiply x, so there's no solution of x and a, so there's no solution of x because when you cross multiply this, x minus 1 multiplies the negative, the 0, sorry. So there's no solution of x. And then y-intercept when x is equals to 0. So we're going to have f of 0 is equals to minus 1 over 0 minus 1 being equals to minus 1 divided by minus 1 equals to 1. So the y-intercept when x is 0, it's 1, like that, right? So we have our intercepts. Now we can draw our function. So what we're going to do is we're going to draw the function just right here, and we're going to label the function, or the Cartesian plane rather. So this is going to be your y and this is going to be your x. And remember that we don't have x-intercept, but we have y-intercept. Y-intercept when x is 0, it's actually 1, right? So let's say this is the y-intercept, 0 and 1, like that. And then our asymptotes, we have our vertical and horizontal, sorry, we're having our vertical and horizontal asymptotes. So our vertical asymptote is equals to 1, our horizontal asymptote is equals to 0. So we're going to identify our vertical asymptote, which is this one here, and say it's x being equals to 1. And then our horizontal asymptote is going to pass through here at y equals to 0. So looking at our function, right, this is our function, right? And for us to identify whether the graph is in the first or third quadrant or second or fourth quadrant, we must look at the value of a, which is this one here. So in this case, value of a is less than 0, meaning that the function is going to be in the second quadrant and fourth quadrant. Hence, if we draw, we're having one intercept here, so it's going to move like that and like that, and then the other part is going to move like that. So this is our graph of f represented in this problem here. Which values of x will x multiplied by the derivative of f of x be greater than 0, right? So remember that we drew our graph, right? Let me just redraw it again. So we had our graph like this, and our vertical asymptotes, x being equals to 1, horizontal asymptotes, y equals to 0, and that was the point. So our graph looks something like that. Right, so here we want to identify the x values, right, such that x multiplied by f prime of x, is it greater? Yes, it's greater or equals to 0, greater or equals to 0. So we want to identify the values of x when x, so this x here is actually y is equals to x, which can be represented, I'm sorry, speaking fast, which can be represented like this. So let's say this is y is equals to x, y is equals to x graph, right? So this graph multiplied by the slope of f, so this is f of x, right? So the slope of f means that we are literally looking at the gradient of the function of f, right? So where, in which point, so let me just label here 0 and 1, in which point of this graph here will we have a point where the gradient is increasing multiplied by a certain value of x will give us a positive solution of y. So we need that point. If we were to here the gradient is positive, here all the way up the gradient is positive, but here okay, it depends on how you interpret it. Yes, it just depends on how you interpret it. If you're going from bottom to up, then definitely the gradient will increase, right? Or if you, even if you consider looking at this straight line of y is equals to x, it is positive, right? The slope is positive, but we're not really concerned of the slope. So looking at the slope is positive, but looking at the x values in this section here, x values are negative, right? X values are negative, but in this section here, x values are positive. Why am I saying this? This is an x-axis, right? In this side of the x-axis, we're having positive x values. This side of the x-axis, we're having negative x values, right? So if you were to take positive values of x in the straight line, looking at this straight line of y is equals to x, if you were to take only positive x values which lie from the origin going in that direction, right? So you'll have positive x values, right? And then you multiply by the gradient. So the graph is increasing, right? Whether you look at it in this side, whether you look at it in this side, the graph is increasing, right? So if something is increasing, it has a positive gradient, right? So meaning the positive x values and the positive gradient will definitely give you a solution that is greater or equal to 0, right? So that is that. And if you were to include the negative x values, then you will need a point where the graph is decreasing to get a positive solution of y. But in this case, we're not interested in that. We're just looking at x values. When you multiply them with the gradient, it gives you a greater or equal to 0 solution of y. So I can simply conclude and say when x is greater than or equals to 0, right? So when x is greater than or equals to 0, so where is that? It is at this point here. X is equals to 0 at this point. But in that direction, x is greater or equals to 0. So when x is greater or equals to 0, but x must not be equals to 1, therefore you will have a situation where the value of x multiplied by the gradient of f will give you a solution that is greater or equals to 0. So that is the condition for us to conclude on this solution. So let's do question 6. So what we have here is, in the diagram below, a and b are the x-intercepts of the graph of f of x being equals to x squared minus 2x minus 3. A straight line g through a cuts f at c, and the y-axis at 0 and 1. Right, so the graph of g cuts f at c, and the y-axis at 0 and 1. So M is a point on f and n is a point on g, such that mn is parallel to the y-axis. Mn cuts the x-axis at t. So we're having our graph here, and all that was read in the statement is represented in the graph. So let's do 6.1. Say that show that the graph of g of x is equals to x plus 1. So what you're going to do is we're having the graph of g of x, this one here, and what we have is this point here of c being 4 and 5, and this point here of 0 and 1, sorry. So we can use that information to find the equation of g of x, right? Because the straight line y is equals to mx plus c, and c in this case is equals to 1 because this is a y-intercept when x is equals to 0. So y is equals to mx plus 1. So we need to find the gradient. We can use both points, the point of 0 and 1 and the point of 4 and 5, this one here. So m is equals to change in y over change in x being equals to, so let's say this is x1, y1, x2, this is 4 by the way, and y2. So we're going to start by saying y2 minus y1 over x2 minus x1. So y2 is this one here, which is 5, minus this one here, which is 1, divided by x2, which is 4, so 4 minus 0. So 5 minus 1 is 4 divided by 4, because 4 minus 0 is 4, which is equals to 1. So the gradient is equals to 1. So y is equals to 1 x plus 1. So it's just going to be y is equals to x plus 1. So this is the equation of g of x. So now let's do 6.2, which says calculate the coordinates of a and b. We were told that a and b are the points of f right? X-intercepts to be specific. So because there are x-intercepts of f, we can simply find the x-intercepts of f using the equation of f of x being equals to x squared minus 2x minus 3, right? So we equate 0, the f of x, right? Equate to 0, so it's going to be x squared minus 2x minus 3 equals to 0. We factorize, we have x and x, and then we have 3 and 1, right? So the 3 should be a negative and this should be positive. So x will be equals to minus 1 or x equals to 3. So looking at the graph, the point of A is at the negative x-axis, so definitely it's going to take the x being equals to minus 1. So it's minus 1 and 0. And the B is in the positive x-axis, so B will take the positive value of x and y is 0. So these are the coordinates of both A and B. So 6.3 says that we must determine the range of f. So for us to determine the range of f, check here, it says 3 marks. We first need to identify the turning point, right? Because the range is talking about the y values. It's talking about the movement of the y values. And the central value that we normally use for the range of a parabola is the y value of the turning point. So we need to get that y value of the turning point, and then we identify the range of the graph. So what we first need to do here is we're going to write our equation of f of x being equals to x squared minus 2x minus 3, and find the x value of the turning point, which is minus b over 2a equals to minus, our b is minus 2 over 2, our a is 1, being equals to 2 over 2, which is equals to 1. So finding the y value when x equals to 1 equals to 1 squared minus 2 into 1 minus 3. So you need to get minus 4, right? So this means now that in this turning point of this graph, we have 1 and minus 4, right? So the range interprets the y values, the movement of the y values. So the minus 4 is the lowest value of y of this parabola. Anything else is above minus 4, right? So the range we will interpret as y being greater or equals to minus 4. Why we put them equal sign is because of the minus 4 being part of the graph. So it starts from minus 4 going up. So those are the movement of y values. So you can simply write y is greater than or equals to minus 4, or someone can write, because y values come from that direction going down, they come from a positive infinity, by the way, and then they go down to minus 4 and then also move up to positive infinity. So someone can also write positive infinity to minus 4 and minus 4 to positive infinity. You can write like this, or you can write y is greater or equals to minus 4. Okay, so 6.4, we were given that mn is equal to 6, right? So now mn is this one here. Let me just erase here. So we are told that mn is equal to 6, so meaning that the distance between this point going down to this point is equals to 6 units, right? Or the length rather So 6.4.1, determine the length of OT if t lies on the negative x-axis. Show all your working. So it's 4 marks. To find the length of OT, so let me erase this so that you can see OT clearly. So OT is thus here, it moves all the way there, right? So and we know that this is actually 6 units, so it tells us the fact that it's 6 units from this point to that point. Mn equals to 6 units, and we want to identify the value of x at t, right? So for us to find that, we need to say Mn is equals to top minus bottom. So what this means is Mn is the length, right? And the top is the top function. So the equation of the top function minus the equation of the bottom function. So which function is at the top? It's this one here, the parabola f of x is at the top. So f of x is the top function minus the bottom function, which is this straight line, or which is g of x, right? So Mn is equals to f of x minus g of x. So let me write it here. Mn is equals to f of x minus g of x, right? Of which we know our f of x, right, being equals to x squared minus 2x minus 3, and our g of x we found in the previous question to be x plus 1, right? So, and Mn we know to be 6 units. So it's going to be 6 equals to our f of x being equals to x squared minus 2x minus 3 minus our g of x plus 1. So it's going to be 6 equals to x squared minus 2x minus 3. The negative multiplies everything inside the bracket, so minus x minus 1. Then we collect the like terms, so it's going to be x squared minus 2x minus 3. Oh, sorry, minus x minus 3 minus 1. Transpose the 6 to the other side, we have x squared minus 2x minus x minus 3 minus 1 minus 6 equals to 0. And we add everything up, we have x squared minus 3x. This will be minus 10 equals to 0. Then we factorize, equals to 0. So x and x, 5 and 2, which this has to be negative. So let me write properly. So it's going to be negative and this would be positive. X equals to minus 2 or x equals to 5, right? So because we are looking for OT, remember that, and we are told t lies in the negative x axis, so meaning that it's going to take this value here of x being equals to minus 2, right? So it means now that t has an x value of minus 2 and the y value is 0, right? So to find OT now, we know that O is from the center. So let's look at the graph. O is from the center and then T is at the x axis. So this distance here, because T is given as minus 2 and 0, which is what we just found, we can simply say 2 is the length of OT. So which is what you can write. So therefore OT is equal to 2 units. Please don't write the negative sign. Just simply take the digit, the number of 2. So it's going to be 2 units. So that is the length of OT. Okay, so let's do 6.4.2, which says hence write down the coordinates of n. So where is n? It's this one here. So write down the coordinates of n. Remember t, the coordinates is minus 2 and 0. So it means n is the same, it's minus 2, but you don't know the y value, right? So to find the y value, because n is touching the graph of g, we'll say the graph of g of x equals to x plus 1, and we want the y value when x is equals to minus 2. So x is equals to minus 2, what is the y value? Y is equals to minus 2 plus 1 being equals to minus 1. So therefore our n has coordinates of minus 2, minus 1. So that is the answer. Okay, so now we're going to do 6.5. It says determine the equation of the tangent to f drawn parallel to g. So we want a tangent of f drawn parallel to g. So we know very well that if it is a tangent, it means now that it will touch at one point of this graph. So let's say, for example, it will move like this. Because it's a tangent of f, it will move like this, right, and touch one point. We don't know which points that would be, but we know that it's going to move like that, right? So what we're going to do is we have f of x being equals to x squared minus 2x minus 3, right? And we were told that the line is parallel to the graph of g. So it means now that the gradient of g is equals to the gradient of tangent is equals to 1. Remember that the gradient of g of x is equals to 1. So now we are going to find the derivative of this. So we have f of x being equals to x squared minus 2x minus 3, right? So let me write it properly on this side. F of x being equals to x squared minus 2x minus 3. M of t is equals to 1. So the derivative here is going to be equals to 2x minus 2, of which the gradient is 1. So 1 is equals to 2x minus 2. Transpose the 2 to the other side. You have 2x being equals to 2 plus 1, which is 2x being equals to 3. Divide by 2 both sides, so x is equals to 3 over 2. So this is the x value of the graph, or let me just say of the tangent, right? That the x value that touch the tangent. So we now want to find the y value when x is 3 over 2. So we're going to substitute in this graph here, equation rather. So it's going to be 3 over 2 squared minus 2 into 3 over 2 minus 3, right? So you're going to punch this in your calculator and you should get an answer of minus 15 over 4. So we're having our y, so x of t is equals to 3 over 2, y of t is equals to minus 15 over 4. So to find the equation of this tangent, we'll say y is equals to mx plus c, of which the y value we have and the x value we have, and we know the gradient of this function is 1, right? So m is equals to 1, y is equals to minus 15 over 4, x is equals to 3 over 2. So we're going to say y is equals to x plus c. We want to find the value of c, so we'll substitute this value of x and this value of y. So it's going to be 3 over 2 is equals to minus 15 over 4 plus c. So transpose this to the other side and you should have 3 over 2 plus 15 over 4 is equals to C. Punch that in your calculator, you should get C being equals to minus 21 over 4, right? Minus 21 over 4 is the value of C. So this is the value of C now. Now we have our equation, right? Because it was y is equals to x plus c, c is equals to minus 21 over 4, so therefore y is equals to x minus 21 over 4. So this is the equation of the tangent. So 6.6 says that for which values of k will the f of x being equals to x squared minus 2x minus 3 and the h of x being equals to x plus k not intersect. So to find the solution for this, we're simply going to say, as to find this, I want us to go back to the graph and remember that we had a tangent, right? So this is the equation of the tangent y of t, and we found the equation of the tangent to be y of t being equals to m of x plus c, which y of t was x minus 21 over 4, right? So the 21 over 4 is going to be somewhere here, right? Let me indicate with a different color. It's the y-intercept of this graph. So let's say this extended here. So it's going to be somewhere here, right, for this graph of the tangent, right? So in this question here, we want to identify where the graph don't intersect at all. But what we know is that going upwards, the chances of the tangent intersecting with this graph of f is possible, right? Because it can intersect at any point here. If maybe we were to just raise it up, right, it will intersect. But just below this tangent here, just below, there's nothing. It's empty, right? As you can see, there's no way that it will intersect with the graph of f, right? So that is our answer. We know the y-intercept of the tangent being equals to so the y-intercept is actually y is equals to minus 21 over 4, right? When x is 0. So which is this point as I indicated. So when y is greater than minus 21 over 4, there is a chance of the graph intersecting, you see. But when y is less than minus 21 over 4, there's nothing. As I indicated, it's empty. So there's no way that it will intersect with the graph of f, right? So hence this is the answer, because the y-intercept is at this point here, and below the y-intercept, any value that is less than the y-intercept does not go towards the graph of f of x, right? So we are going to take the final answer being y less than. We're going to do question 7. We are given so it's 7.1. Selby decided today that he will save 15,000 per quarter over the next 4 years, and he will make the first deposit into savings account in 3 months time, right? And he will make his last deposit at the end of the 4 years from now. 7.1.1, how much will Selby have at the end of the 4 years if interest is earned at 8.8% per annum compounded monthly. So this is an investment, right? So whenever it is an investment, we are going to, and the payment is made quarterly, right? So we're just going to use the future value annuity to calculate the amount of money that will be in the account in the future, right? In a period of 4 years. So we're just going to use the future value annuity, which is f is equals to x into 1 plus I to the power of n minus 1 divided by I, of which our our x, the investment is 15,000 rand, and our I, we are given is it 8.8? Yes, 8.8% per annum compounded quarterly, right? And n is equals to 4 years. So this is just the years, but we know that it doesn't necessarily mean years, so we have to multiply by the 12, by the quarter, right, in the equation. So number of payments, n number of payments. So we're gonna have f of v is equals to the 15,000 that is invested, 1 plus, we're going to change this into decimal form, so it's 8.8% divided by 100. You're going to get 0.088 divided by 4 because it's compounded quarterly, right? And to the power of 4 multiplied by 4 because it's 4 years, minus 1 into 0.088 over 4. So the future value of this investment excuse me, the future value of this investment would give you 283,972.28. so this is the future value of the investment. So now 7.1.2, if Selby decides to withdraw 100,000 rand from the account at the end of 3 years, how much will he have in the account at the end of 4 years? So this is what's happening. We're having a situation where let me draw the timeline because this is very important. My line is just not the one. So this would be your timeline of Selby's investment, where this is T0 and this is T4, right? So investments of 15,000 rands are made T1, so they're made quarterly, right? So I'm not going to write the quarters, but what's mostly critical for me is that he withdraws, so it's minus 100,000 rand at T3, right? So he withdraws that amount. So we want to know how much we're going to have the future value annuity here at T4, right? So what you can do, let me just say the amount, right? Instead of just writing the future value annuity, you can just say the amount, because yeah, this is wrong. Just say the amount. What would be the amount at T4, the accumulated amount, right? So what you can do, because he invests 15,000 rand quarterly, let's find FV from T0 to T3, right? For the first 3 years, we want to identify the future value annuity. In 3 years, we want to find the future value annuity, which is equals to x into 1 plus I to the power of n minus 1 divided by I, right? So the investment is 15,000 rand into 1 plus 0.088 over 4 because it's quarterly, so it's 4 times 3 years, right? 3 minus 1 over 0.088 over 4. So you can punch this and then continue from what I'm about to do, or you can just subtract, because remember, this would be the future value in 3 years, and then what happens in 3 years? There's a withdrawal of 100 100,000 rand, right? So it's either you can punch the entire thing or you can punch the first part. It's up to you. I punched the entire thing. It was possible to do that in my calculator. So okay, this is 0. So yeah, punch this and find the future value in that 3 years now. So FV is going to be 100,000, 3,459.12, right? So this is the future value at 3 years, right? We want the amount in 4 years, so we still have to write down the question. So at 4 years, this is what happens. So what's going to happen is this. Now we want to identify what's going to be in the account in 4 years. Excuse me, after the withdrawal was made, right? So this future value annuity is going to gain, it's going to have experienced some growth, right? From 3 years to 4 years, so which is basically 1 year, because if you write the timeline, it's T0 and then T3 and then T4, right? So now it's the difference between T3 and T4 is just 1 year, right? So we're focusing from T3 to T4, right? Which is basically, we are here, we want to identify A, right? So A would be equals to P into 1 plus I to the power of n. So we're going to add this with the future value. Remember that from T3 to T4, investments of 15,000 rand quarterly are still being made. Hence, I'm going to use the future value annuity to still calculate those investments, right? It's going to be A is equals to this future value annuity, which is going to gain some interest or whatever it is. So it's going to be 103,459.12 into 1 plus 0.088, right? Quarterly, so it's to the power of 4 multiplied by, so let me just say multiplied by 1, because it's 1 year, right? From 3 to 4 years, it's just going to be 1. And we add with the future value annuity of 15,000 rand into 1 plus 0.088 divided by 4 to the power of 4 times 1, right? Because it's 1 year minus 1. So let me just do this. So it's minus 1. Let me write this properly. So it's going to be minus 1, close the bracket, divide by 0.088 over 4. So the amount now, you can punch the entire thing in the calculator if it's possible, or you can punch this first section here and then add it with this section here, right? And then find your amount, right? So the amount that I got is 174,877.60. So that is the amount that would be accumulated in 4 years after the withdrawal was made. Now let's just do another question. 7.2. Tepo takes out a home loan over 20 years to buy a house that cost 1,500,000, right? 7.2.1, calculate the monthly installments if the interest is charged at 10.5% compounded monthly. So let's calculate. We're talking of a loan here, so definitely going to use PV is equals to x into 1 minus into 1 plus I to the power of minus n divided by I. So the loan that was taken by Tepo is 1,500,000, right? And the interest rate for this is 10.5% compounded monthly for a period of 20 years, right? So it's just going to be 20 years. So you're going to multiply it with this in the formula. So we want to identify X, the monthly investments, or monthly payments rather, not investments, sorry, the repayments of the loan. So we're just gonna say substitute from this formula here. We have 1500000 is equals to X into 1 minus into 1 plus. We're going to divide this 10.5 by 100, right? You will have 0.105 over 12 because it's compounded monthly minus 12 times 20 years divided by 0.105 over 12. So we want X. What we will do is cross multiply here. So you're gonna have 1500000 times 0.105 over 12. Okay, let me not put this. Is equals to X into 1 minus into 1 plus 0.105 over 12 to the power of minus 1 2 times 20, and then we divide both sides by this huge expression of 0.105 over 12 to the power of minus 12 times 20, and 1 minus into 1 plus 0.105 over 12 to the power of minus 12 times 20, right? So X is equals to 1500000 times 0.105 over 12 divided by 1 minus into 1 plus 0.105 over 12. So I'm not punching into the calculator as yet until I get this final expression, because I don't want to be getting different answers, you know, towards the person who's going to mark, you know. So you always need to make sure that you round off towards the end. So X, then now you're going to find the answer to the entire expression here. It'll fit in your calculator. So the monthly investment made for this is going to be 14975.70. So this are not investments. Why am I saying that? Monthly payments for this loan, right? It's going to be 14,975.70. So now we're going to do 7.2.2. So this one here, calculate the outstanding balance immediately after the 144th payment was made. So to find the balance outstanding, we're going to equate to the p into 1 plus I to the power of n, and then you minus the future value annuity, right? Future value annuity. So what's going to happen is this. The balance would be equals to, so we're just going to multiply the loan with this here. So the interest rate is 0.105 divided by 12 compounded monthly, and then we were told that the payments are 144, right? So then we're just going to subtract, we know the future value annuity is given as x into 1 plus I to the power of n minus 1 divided by I, right? So, and we know that the repayments would be 14,975.7 into 1 plus 0.105 over 12 to the power of 144 payments minus 1. So this is just 1 here. minus 1 into divide by 0.105 over 12. So the balance outstanding. So now you're just gonna find the answer to this, subtract it to this one here, right, to find the balance outstanding. So the balance that I found by doing that was 969,927.74. Let me know what you're finding in the comments. 8.1, determine f prime of x using first principles if you're given f of x equals to x squared minus 5. So our f of x is equals to x squared minus 5, and our f of x plus h is equals to, so wherever we see x, we want to put this x plus h squared minus 5, and then we want to find our derivative when the limit of h approaches 0. So it's f of x plus h. Please write the formula, don't omit it, h, and then the limit when h approaches 0. So you're just gonna write this expression here of x plus h squared, squared minus 5, right? I'm just gonna put the brackets there, minus into x squared minus 5 divided by h. So the limit when h approaches 0 is let me do this portion here aside. So we're having x plus h squared, which is x plus h, x plus h. I think you've already know this. X squared plus xh plus xh plus h squared, so which is equals to x squared plus 2xh plus h squared. So just gonna write that down. So it's going to be into let me write this. So it's going to be x squared plus 2xh plus h squared, right? And then close brackets, minus 5 minus into x squared minus 5 divided by h, right? So it's going to be the limit when h approaches 0. So we're just gonna take this outside the bracket. So it's going to be x squared plus 2xh plus h squared minus 5, and then this minus will multiply everything that is inside here. So it's going to be minus x squared plus 5 all over h, right? And then like terms will just cancel each other out, so not necessarily like terms. So you have minus 5 plus 5, and then you have x squared minus x squared, and then we're having limits when h approaches 0. So you have 2xh plus h squared over h. So we're just going to factorize with the limits when h approaches 0. So it's h into 2x plus h over h. So we divide out this and we remain with the limits when h approaches 0. So it's 2x plus h. So we substitute this 0 where there's h just here. So it's going to be 2x plus 0. So it's going to be 2x. So this is the final answer of our derivative, right? Always check with your equation. We had an equation of f of x is equals to x squared minus 5. So always check that your answer is actually correct. So the derivative of this is just going to be 2x plus a 0 or minus a 0, whatever it is, but we know it's just a 0. So this is the final answer. So yeah, this is the same as this, which means you did correct. So we're done with this portion of the question. Now we're just gonna do 8.2, where we're asked to find the derivative of this expression in 8.2.1. So to find the derivative of this, we have y is equals to 3x cubed plus 6x squared plus x minus 4. Please indicate how you derive. Don't just give answers. So we're going to drop this 3, so it's going to be 3 into 3x to the power of 3 minus 1. There's marks for this, so you need to indicate 2 into 6x to the power of 2 minus 1 plus 1 minus 0, right? And then now you can write everything properly. So this 3 will multiply this 3 here, so it's going to be 9x to the power of 2 plus this 2 multiplied by 2 is going to give us 12x plus 1. So this would be your derivative, which you can just write as dy over dx, or you can write it like this, it's also fine. So yes, we're done with this question. Let's go to 8.2.2. So 8.2.2, we are also asked to find the derivative of this. Just to write it, you have yx minus y is equals to 2x squared minus 2x. We want to derive something that is y is equals to. Yes, it's possible to derive like this, but you know, I don't think in grade 12 we do that. Let's just simplify and then, you know, factorize the way we need to factorize, just to make sure that our equation is y is equals to, and then we'll derive from there. So what we're going to do is we're going to factorize this y into x minus 1 equals to 2x squared minus 2x, and then we divide by x minus 1, divide by x minus 1, and then we have y is equals to 2x squared minus 2x over x minus 1, right? So now at least we've done something with this expression. So it's y is equals to, so y is equals to, let's factorize the top, because we can find the derivative of this, but we just want to simplify it further. So it's going to be 2x outside, where x minus 1 divided by x minus 1, and you can see that these two here are common, so therefore y is equals to 2x, so the derivative is equals to 2. So that is the final answer of this question. Okay, so now we're going to do question 9. 9.1, the graph of g of x is equals to x cubed plus bx squared plus cx plus d is sketched below. The graph of g intersects at x-axis of minus 5 and 0 and p. The y-axis is given as 0 and 20. So p and r are the turning points of the graph of g, right? So the information is represented in this graph, as you can see. So we're having the x-intercept here and here. So this one is the x-intercept and the turning point of the graph. And then this point here, it's your y-intercept where x is 0. Then this r is going to be your turning point of your cubic function. So 9.1.1, we are asked to show that b is equals to 1, c is equals to minus 16, and d is equals to 20. So what we can do here is this. We will write our g of x in terms of x 1 minus, we're having our x-intercept to be minus 5, right? So you can just write minus 5 here, and then x, let me just rewrite this formula here. So you have g of x being equals to x minus minus 5, right? And then x minus x1, right, squared. So this portion here is just this minus 5, and in this portion here it's this p, right? The reason why it's squared, it's because it's an x-intercept and also the turning point of the graph of g of x, right? So hence I did that. Then you're going to have g of x being equals to x plus 5 x minus x1, right, squared. So what you're going to do here, you can substitute this 20 here, so 0 and 20. So where is g of x, we're going to put 20 is equals to, and then where you see x, this x here, you're just going to put 0. 0 plus 5, 0 minus x1 squared. And then it's 20 is equals to 5 multiplied by x squared 1, right? Divide by 5 both sides, and you should get x1 squared being equals to 4, and then you put the square roots both sides, so x1 is equals to plus or minus 2. So it's definitely not going to be minus 2 because the turning point is here, and the x values are positive on this side, so therefore we will take x1 to be equals to 2. So we now have our x1, so we can simply write our function g of x is equals to x plus 5 and x minus our x1 is positive 2. So we just write positive 2, and then we close the bracket to put square there. So g of x is equals to x plus 5 and x minus 2 squared, right? And then we're going to find the product because we want to find the standard form of this function here. So it's going to be x plus 5, x minus 2, x minus 2, and then g of x is equals to x plus 5. Then you find the product of this one here, and we'll get x squared minus 4x plus 4, right? So g of x is equals to, so we're just going to find the product of this and this, which should give us x cubed and x multiplied by minus 4, so it's minus 4x squared, and then x multiplied by 4, so it's going to be plus 4x, and then plus 5x squared, which is this 5 here multiplied by this x squared, and then minus 20x, which is the same 5 multiplied by minus 4x, and then plus 20, which is the 5 multiplied by the 4. So let's collect the like terms of this function here, and we go to say this x cubed, and then minus 4x squared plus 5x squared is just going to be positive x squared, and then plus 4 minus 20 is going to be minus 16x plus 20. So this is your g of x, where you have your value of a being equals to 1, your value of b being equals to 1, your value of d being equals to minus 16, your value of c, being equals to minus 16, your value of d being equals to 20. So we've proven that b1 is equals to, b is equals to 1, right? And we've proven that c is equals to minus 16, and we've proven that d is equals to 20. So we're done with this question here. Let me just erase. There's 9.1.2. Calculate the coordinates of P and R. So you want to identify the turning points of the function, right? And we already know the function is equals to x cubed plus x squared minus 16x plus 20, right? So to find the turning points of this function, we find the first derivative is going to be 3x squared plus 2x minus 16, right? And then f prime of x being equals to 0, so you're going to have 3x squared plus 2x minus 16 equals to 0. And we're just going to factorize this function here, and having 3x and x there, and we have factors of 16, it's 8 and 2, right? And this will take the sign of the middle term, and this would be negative. So it's 3x plus 8 equals to 0, or x minus 2 equals to 0. So we transpose the 8 to the other side and the minus 2 to the other side. We have 3x is equals to 8, or x equals to 2. So we divide by 8 both sides, divide by 3 both sides. So it's going to be divided by 3, so x is equals to 8 over 3. So this would be the answers here. Just to correct, make a correction here. It's actually minus 8, so we divide by 3 both sides, so x equals to minus 8 over 3. So that is the x values of our turning points. Then we want to substitute to our function of f. So f of x being equals to x cubed plus x squared minus 16x plus 20. So we're going to substitute our x of minus 8 over 2 over 3. Why am I substituting this value and not x equals to 2? It's because x equals to 2 is positive, right? And it's telling me that the turning point is for this one, of which I know the y value here is 0, right? So if I were to indicate the turning point for this one, it's simple. I'm just going to write 2 here and 0. So this turning point is finished. It's just substituting this one here, which is equals to minus 8 over 3 cubed plus into 8 minus 8 over 3 squared minus 16 into minus 8 over 3 plus 20. So you punch the entire thing in your calculator. So this is a negative. Let me just put it there. So yeah, you plug in everything inside your calculator, you should get fx of minus 8 over 3 is equals to 1372 over 27, which is basically 50.81, right? This value here is equals to minus 2.67. Cool. So that is our coordinate of r, which is minus 8 over 3 and 1372 over 27. So that is our turning point of r, this one here. So let me erase here. So let me write the coordinates. It's going to be minus 8. Let me write it properly. It's going to be minus 8 over 3 and 1372 over 27. So erase here. So then we go to 9.1.3. Is the graph concave up or concave down at this point here? Show all your calculations. So what you're going to do here is this. We're having our g of x, right? Our g of x is given as x cubed plus x squared minus 16x plus 20. And the first derivative of this function is 3x squared plus 2x minus 16, right? And to find the point of inflation, to find the concavity, you need to find the equation of the point of inflation. So it derived twice, right? And equals to 6x plus 2, right? What we need to note is this. They said we must determine the concavity of this function at this point here of 0 and 20. So you're just going to substitute 0 and 20. Let me just put the brackets properly here. So 0 and 20. So which means the second derivative, you're going to put x being 0. So it's 6 into 0 plus 2. So which means it's 2g of prime of 0. So what I need you to note is this. When the second derivative is greater than 0, it means that your cubic function is concave up, right? It's just saying that it defines the concavity of the function and it says it's concave up. So when the second derivative is less than 0, it just says that it's concave down, right? So in this case, our second derivative is greater than 0. It's actually equals 2. So it confirms that the final answer here is going to be this one here, which is concave up. Okay. So now we're going to do this section here. It says that if a cubic function, if g is a cubic function, so I'm just going to explain each and everything that's written here. G of 3 is equals to g of prime of 3 is equals to 0. So let's first explain this first portion here, which says g of 3. So g of 3, it's equals to everything that is here, right? It's equals to, it's also g of 3, it's also equals to 0, right? This 0 here. So what this means is this is the x-intercept when this y is equals to 0, right? Y is equals to 0. So this, let me just indicate here, g of 3 equals to 0. This is the x-intercept when y is equals to 0. Fine. So now I've explained the small portion. And then the g prime of 3 is equals to 0. So what this means is the turning point. Remember, when you derive the turning point and you equate to 0, you find the x values of the turning point, of which this x value of the turning point is equals to 3, right? So now we know g prime of 3 equals to 0. It's the x value of the turning point. So the x is equals to 3. Fine. And then let me explain something else here. So now I'm done with this part here. So now I'm going to explain this one here. So g of 0 is equals to 27. So you see this is just a function of a cubic function. When x is equals to 0, your y is 27. So this is your y-intercept. I'm just going to use another color. So g of 0 is equals to 27. So this is your y-intercept when x is equals to 0. Fine. So and then what else should I explain? I'm going to explain this, which is what I explained just in this previous question that we just did in 9.1. I explained, I said when you have the g prime prime of x greater than 0, when you have the second derivative being greater than 0, where x is less than 3, this tells you the concavity of the function, right? I said this, when it's greater than 0, it's concave up, right? It's concave up, right? And then you have g prime prime of x less than 0, this portion here, where x is greater than 3. So the fact that we have this less than 0, concave down, always know that. Then now it's easy for us to draw the function. I'm just going to draw it here in this small space so that you can see everything that we interpreted. So it's going to look something like this. And then the first thing we're going to do, let's indicate the y-intercept, this one here. Y-intercept is equals to 27. So we have 0 and 27. That's the first point. Let's see the x-intercept, and when y is 0, this one here. So we're done with this one. Now we're here. The x-intercept where y is 0, so x-intercept is equals to 3. So it's here. 3 and 0. So we're done. I'm just going to tick everything that we just finished. So this we're done. And then we are here now. g of prime of 3 is equals to 0, so it means the turning point is equals to the x value of the turning point is actually equals to 3, right? So which is exactly what we just indicated here. So which means the x-intercept is also the turning point of the function. So we still consider this, so which means we're done with this statement here. And the critical part is this one now. Now that you've indicated your points, this is the critical part, this one here, the concavity. So just before x, when x is less than 3, we're talking about these 3 here. When x is less than 3, right, we're looking at this direction. So when x is less than 3, your g of prime of prime x is greater than 0, so which means it's concave up. It is a smiley face. It's this one. It looks like this, but obviously we can't write everything because it's a cubic function. We can simply write one portion, which is this one here on the left hand side. This portion here, we can simply write that. So which means it's concave up, right? Concave up. So let me see which color can I use to draw this. Let me use this one here. So it's concave up, so it's gonna look like this, right? Cool. So it's just gonna continue like this. And then now let's look at this part here. Alright, g of prime of x is less than 0 when x is greater than 0. So when x is greater than 0, it's concave down. So now it's set like this. So, but we're just going to consider this portion here. So we're just gonna say it's going down, concave down, right? So that is how our function look. Function of g, we made sure that we indicated all the intercepts and we labeled our x's. So this is y and this is x, right? And yeah, that's how you draw the function. So please don't forget how to interpret the concavity of the function. And yes, hope it was simple enough to do. Do question 10 in triangle A, B, and C. So D is a point on AB, and E is a point on AC, F is a point on BC, and such that this is a parallelogram DECF, right? And we are given that BF, the ratio of BF FC is equals to 2 is to 3, right? And the perpendicular height AG is intersecting DE at H. AG is equals to T units and BC is equals to 5 minus T units. So most of okay, so now what we can do is we can just answer the questions that follow, right? So 10.1, you asked to write down the ratio of AH is to HG rather, right? Which AH is simply this one here, AH this one here, and HG is this one. How we're gonna find it? We'll find it using BF, this ratio here. BF is to FC, so BF, this one here, BF is to FC, right? So we can simply say because of parallel lines, HG, right, or let me just write AH over HG is equals to it's equals to, so AH can be equals to the bigger side, right? The bigger side, which is GC divided by BF, right? But we know that these, the ratio is actually, so GC is equals to so to find AH is to HG, which is AH over HG, right? What we need to do is this BG, right? No, BF, not BG, BF to FC. So what you're going to do is this ratio of AH is to HG is the same as, because AH is the longest side, so it's FC over, what is it, BF, which is equals to, FC is equals to 3, and then BF is equals to 2. So therefore, AH over HG is equals to 3 over 2. So that is the ratio of this problem here. So now, 10.2, we are asked to calculate T in the area of the parallelogram if the area of the parallelogram is a maximum. And we are given a hint on the area of a parallelogram. So what we can do here is this. Firstly, we are given that AG is equals to T, right? So I'm just gonna write BF over FC. It's equals to 2 over 3, right? We were given, there it is. So it's also equals to AH over HG, right? So another thing that we need to note is that AH is this large side over HG. It's equals to this BF over FC, right? So another thing that we should notice is that AG, let me just remove this. So AG, which is this long side, is equals to the 3 and the 2 here, which is 5. So it's equals to 5, right? And then what we can say is that BF over BC is equals to 2 over 5, right? BF, it's this one here over BC, right? The entire thing, BC, it's equals to this ratio that I just wrote. It's also equals to, so BF, we don't know the actual value, but BC we're given in this problem here. So we're given that BC is equals to 5 minus T. So divide by 5 minus T, like this. And then we cross multiply to find BF. So 5 BF is equals to 2 into 5 minus T. So BF is equals to 2 over 5 into 5 minus T, right? So that is BF. Why am I calculating BF? I'm calculating BF so that I can be able to find HG, right? It's very important, HG, because the whole purpose now, it is to find the area, this area here. So for us to find the area, we must find the dimensions of this parallelogram, right? So what we have now is this. So let me do this. So now we have BF being equals to 2 over 5 into 5 minus T. Let me write it as equation 1. So now we are going to say BC, which is the longest side, because we are mostly interested in this small side, or let me say the other small longest side, but of the parallelogram FC. We're mostly interested in that. But you know that BC is equals to the combination of BF plus FC, right? And we know BC, the value of BC, we know it, but we want FC. So FC is equals to BC minus BF, alright? So BC is equals to what? We know very well that BC is equals to 5 minus t. So it's going to be 5 minus t minus BF is what we found here to be 2 over 5 into 5 minus t, right? So this is FC, right? But to write it properly here, we can say FC is equals to 5 minus t minus 2 over 5. 2 over 5 into 5 minus t. So you're just going to factorize 5 minus t, right, into 1 minus 2 over 5 equals to 5 minus t into, so the 1 minus 2 over 5 will give you 3 over 5. FC is equals to this value here. And then, so now that we found FC, right, now that we found FC, we need to get the perpendicular height. So now that we know FC, this portion here, we know this portion here of FC. So now we need to find this perpendicular height here, this one here, HG, right? So for us to find HG, is the following. We know very well that HG over AG is equals to 2 over 5, right? Which is equals to HG over, so HG is equals to T. We were given that it's equals to T. Let's check. AG was given as T, yes. So now we're just going to cross multiply to find HG. So HG is equals to 2t over 5, right? So that is HG. So I'm talking about this one here. So now we have the dimensions of the parallelogram, right? So we can now find the necessary area of this parallelogram. So just to remove everything here, so I have HG, which is equal to 2 over 5t. Now to find the area of a parallelogram, so its area is equals, of a parallelogram is equals to base multiplied by perpendicular heights equals to, so the base is FC, right? So it's FC, which is 3 over 5 into 5 minus t multiplied by 2 over 5t, right? So we're gonna have 3 over 5 times 2 over 5 into 5 minus t, right? Which is equals to 6 over 25 into 5 minus t. So that is this, and then not forgetting that it's multiplied by t, right? So it's going to be 6 over 25 into, so the t will multiply everything that is inside, so it's going to be 5t minus t squared, right? So this is still the area, so this is still the area, right? So the area is equals to, I'm going to multiply this inside. I will have 30t over 25 minus 6t squared over 25, right? So that is the area of this parallelogram, right? So because we are looking for the value of t, which at the end we need to derive, right? So I'm having a being equals to minus 6t squared over 25 plus 30t over 25. So a or prime of t, which is equals to 2 times into minus 6 over 25 plus 30 over 25. A prime of t is equals to from here we just gonna multiply 2 times this, is going to be minus 12 all over, so not forgetting that this is t squared, right? And which means there's t, so let me just rewrite this. Let me rewrite this derivative. So it's a equals to a prime 2 times negative 6 over 25 t plus 30 over 25. So a prime is equals to minus 12 over 25t plus 30 over 25. So a prime is equals to 0, meaning that transposes to the other side, we have 12 over 25t is equals to 30 over 25. Therefore t is equals to, so I'm just going to divide out this expression here. So it's 30 over 25 divided by 12 over 25. So you should get t being equals to 30 over 12, which is the same as having 5 over 2. So that is your value of t. So now we're going to do question 11. We are given the following digits of 3, 4, 5, 6, 7, 8, and 9. 11.1, we are asked to calculate how many 5 unique digits can be formed using the digits above. So 11.1.1, we are told that the digits may be repeated. So what's happening is you want to create a 5-digit code, right? And you are given all these digits. How many are these digits? 1, 2, 3, 4, 5, 6, 7. So you have a total of 7 digits. And if these digits were to be repeated, which means now that for the first digit, there's 7 ways. We have 7 options rather. We can either have the 3, we can put the 4, we can put the 5, we can put the 6, we can put the 7, we can put the 8 or the 9. So I mean, we have 7 options to put the first digit, right? And the second digit, it's also 7 options, because there's also a chance that even if we put the 3 in the first digit, since we are told that it's repeated, we are also allowed to use the 3 for the second digit. So we are allowed to use the 3 and all other digits, right? So it's going to be 7. And the third digit would be 7 options to choose from. So the 7 will just continue because the digits may be repeated. So we can have 7, 7 like that, right? So that is how we are going to solve this problem here. 7, 7, 7, 7. So meaning the answer now, you're going to say 7 times 7. Oops. So you're going to say 7 times 7 times 7 times 7 times 7, which is basically 7 to the power of 5, right? It's 5 digits, and the answer to this is 16807. So this is the answer for this problem here. And then now we are doing 11.1.2, where we are told that the digits may not be repeated. So having a 7-digit code, the options that we have to choose for the first code are 7, right? All the options, right? And then for the second code, since they are not repeated, which means if we used 3 initially, then we're not allowed to use 3 again, right? So which means we'll have how many codes left, or how many numbers left? We'll have 6 numbers left. If we use this 4, how many do we have left? We have 5 left. If we use this 5, how many do we have left? We have 4 left. If we use this 6, we have 3 left. So that is how we're going to do this question here. So it's going to be 7 times 6 times 5 times 4 times 3, which the answer for this one would be 2520. Okay, so now 11.2, we want to create 3 unique digit code. Following these instructions, digits may be repeated. So let's first start with this condition. When digits are repeated, yes, we're having a 3 digit code, right? If digits are repeated, then we know that all these digits apply, right? All these digits apply. And how many are they? There are 7. So which means the first condition has been solved. So so it's going to be 7, and then okay, let me first remove this and say for here it's going to be 7, right? And then the code is greater than 400 but less than 600. So looking at these numbers, right? Looking at these numbers, if you were to represent them in the 3-digit code and represent them in such a way that they will depict, or they will show a number that is greater than 400 but less than 600. So if you were to put maybe 3 here, if you were to put 3, 4 and 5, 3, 4 and 5, 3 is just not greater than 400, so you can't consider that, but you can put 4, 5 and 6, right? So which is 456. So 456 is greater than 400. So that's one way of putting it, and of doing the code. That's one way. And another way of doing it is by using 5 instead, by using this 5 here, which is going to be 5, 6 and 7, which is 567. It's also above 400 and less than 600. So that's another one way of doing it. So you can't, now we can't use 6, 7 and 8 because already 6 is above 600. So how many ways do we have for this second option here? We have 2 ways, because this is one way, this is another way. So we have 2 ways of doing it. And then here the code is divisible by 5. So we're just going to look at numbers that are divisible by 5. The code is divisible by 5, right? So we're just going to look at a number that is divisible by 5 from these digits here that are given. There's only one number that is divisible by 5, and that is 5. The rest are not divisible by 5, right? So meaning there's only one number. So now we can represent this down. We can say our 3-digit code will have one number that is divisible by 5, and we'll have 7, which is repeated, and we'll have 2 ways of writing the code greater than 400 but less than 600, which will give you 14, right? So this would be the answer for this problem here. Okay, so now we're going to do the last question of this paper here, which is question 12. 12.1, we are given the probability of A, probability of B, and probability of A or B. So we are asked to find the value of Y, right? If A and B are mutually exclusive, so meaning that the intersection of A and B is equals to 0, right? So what we'll do is this. Let me just write on another side. So we're having the probability of A being equals to 0.45, probability of B being equals to Y, probability of A or B being equals to 0.74, right? So the probability of A or B is equals to probability of A plus probability of B. Remember, the intersection is 0, so it's going to be 0.74 is equals to 0.45 plus Y. Transpose this to the other side, you have Y is equals to 0.74 minus 0.45. And then you minus this using your calculator, you should get 0.29. So this is the answer for the Y value. So now the last question says that an organization decided to distribute gift bags of sweets to a grade R class at a certain school. The mystery gift is exactly 1/4 of the total number of bags, right? So we have mystery gifts of 1/4 of the total number of bags. Each learner in the class may randomly select 2 bags of sweets, one after the other. The probability that a learner selects 2 bags of sweets with a mystery bag is actually equals to 7/118. Calculate the number of gifts bag of sweets with the mystery gift inside. So what we can do here is first represent this situation in a tree diagram, which will make it more sense. So the gift bag, the bag with sweets and the bag with the gift, right? So the probability of getting a gift bag, it's actually 1/4, right? It was told that probability of getting a gift bag is 1/4, right? So, but what we need to note is that the number of mystery bags we don't know, so it's x, but the total it's actually equals to 4x, right? So hence it's 1 there and then it's 4 there, so you're just gonna put x here, and then the probability of choosing sweets, so you're just gonna say 1 minus 1/4 to get the probability of sweets, which would be 3/4, right? So it's gonna be 3/4, x and x there. And then now if we have sweets gift bag and sweets gift bag, so we want to identify the number of gift bags, right? So the only thing that can help us is to look at this side of gift bag. So this is a gift bag and this is another gift bag, right? So let's look at these, which will help us identify the number of gift bags. So if we take another gift bag from this 1/4, which means we'll remain with, because there's, if we assume that nothing is replaced, right? We don't replace once we take a bag. So we will have 1x minus 1, right? So meaning this minus 1 says that we are taking from the bag. We are taking 1 gift bag and we're not replacing the total. So 4x minus 1 means that nothing is replaced, right? Once you take the less bags remain, you see. So for us to solve for the number of gift bags, remember that x represents the number of gift bags, right? We don't know that x, we want to solve for that x. And remember that the probability of getting these mystery bags is actually 7/118. So using the tree diagram, the probability of getting these gift bags is g multiplied by g, right? Which is 1x over 4x multiplied by 1x minus 1 over 4x minus 1, right? So this probability is equals to the one given. So what you're going to do is this. you have the given one, which is so the probability of these gift bags, it's 118, right? So you're given this, it's equals to the x over 4 x multiplied by x, x minus 1 over 4x minus 1, right? So these two are equal. So what you can do is you're going to solve for x. So it's 7 over 118 equals to 1 over 4 into x minus 1 over 4x minus 1. So we're going to solve for x here. So you can divide by 1 over 4. Divide by 1 over 4 both sides. And you will get 14 over 59 is equals to the x minus 1 over 4x minus 1. And then you cross multiply, you should have 14 into 4x minus 1 is equals to 59x. Let me just do this. So it's going to be 59 into x minus 1, right? So we're just going to multiply inside for both. So you're going to say 14 multiplied by this, multiplied by that. So 14 multiplied by 4x should give you 56x minus 14 is equals to 59 times x is 59x minus 59, right? Collect the like terms. 56 take it that side and minus 59 take it that side. So we have 59x minus 56x equals to 59 minus 14, right? So 59x minus 56x should give you 3x being equals to 45. And then you divide by 3 both sides, so you're gonna get x being equals to 15. So these are the number of mystery bags. Number of mystery bags. Okay, so that's it for this paper. We are done with solving everything. All the best with your exam. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.